Hello, my name is Evan, and welcome to my course on introductory statistics. In this video, we're going to be discussing the normal probability model, explaining how to work with normal distributions and answer questions dealing with probability. The normal model is one of the first major theoretical concepts that you're introduced to in any beginning stats class. Whether you're working with biology, just basic introductory statistics, business stats, or political science, you're going to encounter this model, and it becomes the foundation for the more difficult later chapters. After watching this video, you should be able to define and explain this normal model, know when to imply and how to create the normal model, understand the empirical rule, and finally to be able to answer basic probability questions. So what is this normal model? First off, the normal model depicts probability of occurrence amongst a sample or population. So for example, it might show the likelihood of getting a certain score on a test for a group of students or perhaps an entire classroom. This normal model uses descriptive statistics, using the mean and standard deviation to create a graph of possible outcomes, such as these test scores. When do we want to use this model? First off, it can be used for either sample or population level data. Second, we always want to use the normal model when our sample or population has a sample size greater than 30. When we have a sample or population greater than 30, we can be pretty certain that what we have is a normal distribution. Finally, we want to always use the normal model for continuous outcomes or variables. These are variables such as age, weight, height, SAT scores, BMI, or perhaps you can get more complicated in looking at voting percentage in a district. So let's take a look at this normal model. So here's a picture that should become pretty familiar as we work through this. As you can see, this normal model has something called a bell curve to it. There's a large center with sloping sides both above the center and below. This normal model is symmetric, meaning that 50% of probability is above the center and 50% is below the center. Under this total curve is 100% of probability. An important aspect of this is that the sides actually never touch the x-axis. The probability becomes smaller and smaller and smaller ad infinitum, but it never crosses or touches. A theoretical concept called the empirical rule, or sometimes called the 68, 95, 99.7 rule, tells us that this normal distribution has specific characteristics to it. First off, at the center of our model is the mean, or the expected outcome. From this mean, we use our standard deviation to fill out our model. First off, we add and subtract one standard deviation from the mean. Between this, x bar plus s and x bar minus s bracket is 68% of probability. We continue this method adding and subtracting another standard deviation from these plus 1 brackets. Between the x bar plus 2s and the x bar minus 2s brackets is 95% of total probability. Finally, we create a final third bracket. At the x bar plus 3s and the x bar minus 3s mark is 99.7% of probability, or nearly all. Statistically, points that lie beyond these x bar plus 3s and x bar minus 3s points are kind of defined as outliers. As you can see, the probability of them occurring is about 0.3%. While these three brackets are the most important to memorize in terms of the percentages, it is also worth looking at a couple of other percentages within the model. First off, at the x bar to the x bar plus s point is half of 68%, so 34%, right? And you can see that on the other side as well. As you continue on from the plus 1 to plus 2 part, that is 13.5%. We continue on adding in kind of these basic probabilities that can help you do kind of quick math when you're working on problems. So now let's go ahead and create this model using actual data. So let's say we have a group of 35 students who just took their final exam for their biology class. The mean test score for this group was an 83, and the standard deviation of the group was 2 points. So let's fill out a normal distribution of this class using the empirical rule. First, let's place our mean or expected outcome of 83 at the center. Second, we're going to create our one standard deviation brackets. So what we're going to do is add and subtract our standard deviation that we got of 2 from the mean of 83, giving us 81 on the low end and 85 on the upper end. We now know that 68% of likely test score outcomes will have a score between 81 and 85. We continue on creating this model by subtracting and adding another standard deviation to these brackets. So this gives us 79 on the -2 point and 87 on the +2. This incorporates 95% of likely outcomes. Finally, we want to create our +3 and -3 brackets. Repeating this process gives us on the lower end 77 and on the upper end 89, including 99.7% of all probability. So from this model, we can answer a couple different basic questions about our data. For example, the likelihood that if we selected a random student from the class, that they had a test score between 79 to an 87 would be 95%. Or we could expect to see 34% of students in the class to have a score between 81 and 83. So this concludes our brief introduction into the normal model. In the next lesson, we're going to be looking at z-score, applying it to normal distributions, and looking at 5 different types of z-score questions you can expect to see on quizzes and tests. The rest of this video contains a couple different practice problems with answers that you can work through. Let me know if you have any questions or concerns or comments in the comment section below.